In order to graph one period of a cosecant function, I'm actually going to begin by graphing one period of the reciprocal function, which would be sine in this case. So really, I want to begin this problem just pretending it says 2 times the sine of 4x. And the good news is all the things we've learned before still apply. For example, the amplitude of the sine graph would be 2, the a value in front, and the period of the sine graph would be 2 pi divided by the b value, which is 4. So that simplifies down to pi over 2. There's no reflection this time because the a value is positive, and there's been no vertical shift. So I'm going to begin by graphing the sine function. I'll show you how at the end we'll kind of change things up a little bit to graph what we're trying to actually do, which is the cosecant function. So I'll begin the same way as always by kind of just showing this positive section of my graph. The period's pi over 2, so let's go ahead and get those values on our graph first. So pi over 2 would be the end length of the period starting from 0. I would need the halfway point, same as we've done before. If you need help finding these points, you can watch one of my graphing a sine videos. I would need half of the halfway point, or the quarter point, so pi over 8, and then this point over here would be 3 pi over 8. Okay, I'll also want to label my y-axis with the amplitude, which was 2. And since there was no vertical shift, the midline's just the x-axis at 0. So 2 and negative 2 are the values I'm looking at. Alright, so at this point, I want to go ahead and actually graph my sine function, but remember, we're not really graphing the sine function, it's just kind of there to help us see where the cosecant function would be. Oops, I forgot one thing, I have to add my points on. So the sine function begins at the midline, from there it increases, drops back to where the midline would be, goes to its low value, the minimum, and then back to the midline, and then repeats forever like that. So let's go ahead now and graph my sine function, but at this point, I'm actually going to just do this with a dashed line because this graph's not really the one I'm looking for. It's the reciprocal of this that I'm looking for. So I'll go ahead and finish that. And finish this over here. Okay, so it turns out that now to graph the cosecant, I'm going to first go ahead and add in some vertical asymptotes. The vertical asymptotes are going to occur every time that sine function touches the midline. So at 0, there's going to be an asymptote. Because the reciprocal of 0 is undefined, there'll be an asymptote right here at pi over 4. When I go to graph the cosecant, and then finally there'll be another asymptote here at pi over 2, and of course these would repeat forever. Now that I have all this done, I actually haven't graphed anything yet that I can actually see. All of these are invisible things, but everything's now set up to go back and actually graph the cosecant. So what's going to happen is your graph is going to be a series of u's, where the low point of the u would be the high point of the sine function. So right there is going to be one part of the period, and they share this point right here, so pi over 8 comma 2 is a coordinate on both graphs. And then finally there'll be a u down here. Again, the high point of the u is the low point of the sine graph, and it will be trapped in between those vertical asymptotes. So those two blue u's together show one period of this cosecant function, and those would repeat forever in both directions. And so that's how we're going to be graphing cosecants, by graphing first the sine and then sort of taking the reciprocal of that graph, if you want to think of it that way, to get this series of u's.